Hi, everyone. This is Brittany with Made for Math. Thanks for tuning in today. Today, I'm going to do a short intro lesson to basic trigonometry. So let's go ahead and get started. So if you think about the word trigonometry, well, if you look into it, it actually comes from two Greek words. One, trigonon, meaning triangle. The other, metron, meaning measure. So if we put that together, we get measuring triangles. So trigonometry is all about measuring triangles. Now, trigonometry can be used in other ways as well. Often trigonometry is used with circles and to measure wavelengths and different more complex things. But today we're going to talk about just the basics of trigonometry. So when talking about triangles, trigonometry can help us find angle measures. So how many degrees are in each angle of a triangle, as well as the missing side lengths. Now, if you've already learned about Pythagorean theorem, you might say, well, why do we need this? Because we can use Pythagorean theorem to find the missing side of a right triangle. And you're right, but the helpful thing about trigonometry is if you just have the angle of one angle of the triangle and one side length, you can actually use that to find the other side length. Versus Pythagorean theorem, you cannot do that. And trigonometry is also helpful with other types of triangles as well, besides just right triangles. So that's a little bit of a difference between Pythagorean theorem and trigonometry. Now, basic trigonometry only works with right triangles. So remember that a lot of the ratios and formulas we're going to look at later on will work just with triangles that have a 90-degree angle. And we know that because it has this square box in the corner that signifies 90 degrees. Now, let's talk a little vocabulary. So if you've done any algebra in the past, you often know that the variable x is used to represent an unknown quantity, or really any letter of the alphabet. But with angles, it's a little bit different. For angles, we use actual Greek letters. And the most common Greek letter used, kind of like x, is theta. And this is the symbol that I've highlighted here for theta. And all that means is it's an unknown angle measure. Okay, so think of theta as like x for angles. Now, you also, if you are familiar with right triangles, you probably already have heard of the term hypotenuse. So hypotenuse is that longest side on our right triangle. If you look at the root word of hypotenuse, it actually means stretching under the right angle. Now, I like to think of it more as stretching across from the right angle, because as you can see, depending on how the triangle is turned, it may not always be under the right angle. Then we have, based on the angle that we're looking at, based on our unknown angle, theta, we have the opposite and we have the adjacent sides of the triangle. And those will change based on the angle or based on the theta that you're looking at, okay? So the opposite side is the side directly across from the angle. If someone is sitting across the room from you, they're sitting opposite of you, okay? Adjacent is the side that shares an actual edge with your theta angle. If someone is sitting adjacent to you, they are sitting next to you. So the adjacent side is next to the theta angle or the unknown angle. Okay. So now let's practice that for just a second, because in order to compute trig ratios, we need to first be able to identify these three parts of our right triangle. So if we're looking for the opposite side Well, remember, that's the side opposite the theta angle. So if here's our theta angle, we're going to draw a line across from here. And we can see there it is. So if we want to color code it the same color here. Oops. This right here is side AB. Okay. And then the adjacent side, adjacent shares a side with the angle. Well, I know this one and this one are both adjacent, but remember, one of these has to be our hypotenuse. So which is the side that stretches under the right angle? Here's our right angle. If we go straight across, we can see the hypotenuse is side AC, and the adjacent side is side BC. And on this first example, again, I'm going to color code that so you can see what that looks like. So here's the adjacent side, and here is the hypotenuse. Okay. Now let's do a few other examples. On these, I'll just write the side for each part. So the opposite side. What side is opposite the theta angle? Well, PQ is. What side is, I'll go to the hypotenuse next. What side is stretching under the right angle or opposite the right angle? PR. And then from there, that leaves the adjacent side, which shares a side with our theta angle, which is RQ. So I always find it most helpful to do the hypotenuse first and the opposite side, and then do the adjacent last. One more example. Here's our theta angle. And if we're going to look at the opposite side, go straight across, that's ZY. Okay, the hypotenuse, careful here, find that right angle. This one actually follows that definition of stretching under the right angle. This side right here, XY, is under the right angle. And then finally, the adjacent side, well, what's left? This XZ over here. Okay. All right. So now, say it with me, Sokahtoa. I'm sure many of you may have heard this phrase before, but you may have not understood it or know what it means. Well, this is just simply a little mnemonic device to help you remember the 3 trigonometric ratios for right triangles. When talking about trigonometry ratios, the three you've probably heard of are sine, cosine, and tangent. And what Sokahtoa is just referring to is the ratios for each of those thetas here. So for sine, we have SOH. That's where the so comes from. Sine, opposite, hypotenuse. For cosine, we have C adjacent divided by hypotenuse. That's the K. And then TOA is the tangent equals the opposite over the adjacent. Okay, now that's a lot to take in. So I'm going to do a couple different separate videos going over each of those ratios in particular, and talking about how can we use these ratios to not only find the missing side of a right triangle, but also to find a missing angle. Okay. Now, if you haven't checked out Passy World of Mathematics, he has some really neat color-coded visuals on his website, as well as some real-life application for trigonometry. So here's another great visual for how you can use this mnemonic device, as well as these little triangles to help you work through some trigonometry ratios. Okay, and here is a YouTube video link that is super awesome that talks about real life application of trigonometry. Because I know a question that a lot of students ask is, well, when am I ever going to use this stuff? Well, trigonometry is actually applicable to architecture, engineering, video gaming, oceanography, astronomy, and many, many more topics and careers. So check it out and be on the lookout for some other trigonometry videos I'm going to be making that specifically go over each ratio and how to use it. Thanks again for tuning in. And if you would like more information on multisensory math, please check out our website at madeformath.com. Thanks and have a great day.